algebraic proofs for the most part, except for the very last proof was not an algebraic one. It did have some angles in there, so we kind of need to talk about the angles. So if you have a proof, how do I set it up? What did I ask you that I should at least do? The minimum thing you could do for the proof. What would I do? Create what? 2 columns. And what are going to be the headings of those 2 columns?
Statement and reason.
Okay, so we at least can get that one. We also know that the first statement is always going to be what's given to us. So here it's the measure of angle PMN is equal to the measure of angle RBC. And what is always the reason for that? It's given. We know that. Now, I don't know how many steps are in between, but I know that my last step should be the measure of angle ABR is equal to, plus, sorry about that, plus the measure of angle PMN is equal to the measure of angle ABC. And I don't know what number step that is, I just know it's down there at the end. And that is the same format for every proof that we ever do, right? Nothing's changed. So let's fill in what we do know. Let's kind of look at the picture. And about 4 or 5 of you got this correct. So those of you who didn't get it correct, got a 6. Tell me what you need to do next. If you look here, we're looking for things that add to the ABC. ABC is the entire big angle. Are there a couple of things right now that add to the ABC? What would they be? Good. Okay, so I can say step 2, the measure of angle ABR plus the measure of angle RBC is equal to the measure of angle ABC. Would you agree with that? Those 2 things added together add up to the whole thing. Agreed? We call that the angle addition postulate. It's okay if you just wrote addition, because it's really true. You're just adding the 2 angles, right? The 2 angles added together form the whole angle. You can go ahead and just call it angle addition. Technically, it's a theorem, then a postulate, and then properties are below that. I don't care that you know that hierarchy. It doesn't matter. It's just know that it's a fundamental thing that we know about geometry. Okay? Angle addition. We know what addition is. You add 2 things together. So now look. Believe it or not, we're done. Almost. Because this is step 3. Notice what we have here. They both equal ABC. From this step to this step. ABR is also both there. What's the thing that's different? PMN and RBC. What do you notice here? So how can I replace one with the other? Substitution. So the third step is substitution. That's it. Okay? The 4 or 5 of you that got it. Awesome job. Does that make sense? Looking at it now? Marvin, are you okay with it now?
Yeah. Did you take my picture, right?
I did. You get it right?
I don't know. I think I'll say 1 week. Yeah.
Okay. You can put that away now. You can leave that in the logic section if you would, because proofs really work with the logic section in your binder. We are moving on to a new section, okay, called triangle properties. So this should be the, what section of your binder? So far we have foundations, coordinate geometry, parallel lines, logic, and now triangle properties, right? So foundations like 0. And then we had 1, 2, 3, 4. So you have 0 through 4. So 5 total sections. Okay? I will give you a card stock page for this, but not today. Okay, today we're going to kind of look at some basic things that you should already know, but we'll just kind of make sure. We've already created our foldable. You should have stapled it across the top, and we've named it Triangle Properties. I want you to go ahead and open this. And on the top page, kind of small, I want you to write the words classify by sides, and under the bottom here, classify by angles. Okay? So, we're going to classify by angles and classify by sides. Let's start with sides. So again, classify by sides, classify by angles. Write kind of small because you're actually going to glue these things down. You're going to put these words here, but you're going to find with the little triangles that you cut out, you're going to find an example of a scalene triangle. You're going to find an example of an isosceles triangle and an example of an equilateral triangle. So go ahead and do some sorting for me. Look at the ones you cut out and sort them up. Find the three that go with classify by sides. Tell me what they look like. We should probably define these. What's equilateral?
All the sides equal.
All the sides are congruent. Okay? What's an isosceles?
Two sides equal, one not equal.
Be careful. I'm going to say it again. Marvin, I want you to say your definition, and it's not totally accurate. But listen to why. So I said, what's isosceles? And you said?
Two sides that are equal to one that is not.
Okay. That is an isosceles, but that's not the definition. The definition is at least two sides congruent. So it could have all three, okay? But you have to have just two. Yes?
So an equilateral triangle.
An equilateral triangle is also isosceles. Very, very good. Okay? Scalene. What's that one?
One that all sides are not congruent.
Yeah, all sides are different. Okay? So find those examples in your foldables, and I want you to glue them with your glue stick. One of these folded sides down. One of them will pop up. That's okay. But your scalene triangle, when you put it in your foldable, is the one that looks like this, where you have 1, 2, and 3 sides. All sides are different. Your isosceles triangle, you have to be careful because remember, it is at least two sides congruent. Could have all three. You probably should write that down because it could have three. It could have three. And then equilateral was the one where they all were congruent. So take a second and actually glue those down. It might be easier to glue the paper down, glue on the paper, rather than try to glue on these little tiny things, but it's up to you. Once you've labeled all three of these, the next grouping is classify by angles. And unfortunately, we only have 3 pictures here. So I will tell you that this guy, the acute guy, we're going to put along with equal angular. Although maybe we should, because it can't be both. Leave him off to the side, okay? If these 3, obtuse, right, and equal angular, are the 3 remaining triangles that you should have. We'll just hand draw in a different acute angle, or acute triangle. But go ahead and classify these, and let's put these in their right spot. Leave a space for acute. We're going to add him in a minute, okay? On the right triangle, we're going to label the sides of the triangle. So you don't want to write the word right underneath it or above it. Write the word right on the triangle. So if you need to erase it, that's okay. I had to erase mine too. So go ahead and write the right triangle right in the middle. And I'll tell you how to label the sides of it in just a second. Okay? Equal angular. I always say it wrong. Notice I always say equal angular. And it's probably because I'm so used to thinking all the angles are equal. But there's no L in it. It's equiangular. I just say it wrong all the time. So I apologize. I mean, it's pronounced equiangular, but is it okay if you had to say equal angular? All right, so equal angular. We need to add the measures, okay? All the angles are congruent, so we should mark them all the same. They're not marked that way on the picture. Would you agree? So we need to mark them that way. Okay? Actually, we can go further. Do you guys know what the measures are?
60, 60, 60.
They're 60. We'll talk about line in a minute, but they are. They're all 60 degrees. Good. Obtuse triangle. We have this big obtuse guy. We probably need to talk about why an obtuse triangle is an obtuse triangle. Why is it?
Because
One besides Mark. No Mark. Who else knows? Why Why is that an obtuse triangle, John? Perfect. One of the angles, and notice he said one, because only one of them can be bigger, right? If you had two really big angles, it wouldn't make a triangle. Okay? So we have one obtuse angle. Let's make it obtuse. Give me a measure that would work. 92 would work. This looks a little bigger than 92, but I agree 92 would still be obtuse. I think 120 just looks like it could be that. So let's write 120 in there. Okay? So I agree. One of the angles is bigger. Now, the right triangle, we need to label all the sides. Okay? This is what I want you to do. One of the sides is called the hypotenuse. You know which one it is? One of the largest, which is also across from the right angle. Good. So I want you to label it that way. This is the hypotenuse. Tricky to spell, but I'm facing you. Do you know what the other two legs are called? Somebody else. Any of you know? They're called legs. Very good. And they're both legs. Sometimes they're congruent, sometimes they're not. Okay? So we don't know necessarily if they are. Sometimes it's an isosceles triangle. Sometimes it's not. Okay? Now, why do you think I didn't have an acute picture up there? What would an acute triangle look like? What does an acute triangle look like? Are one of those up there acute? Yeah. Which one is acute? So equiangular is also acute. I agree. All equiangular triangles are acute. Are all acute triangles equiangular?
No.
So we should probably draw a separate picture for it. Okay? An acute triangle is a triangle in which all three angles are what? Smaller than 90. Okay? Smaller than 90. So I don't care how you draw it. Let's just put some numbers in there. Let's call this one 50 degrees. Let's call this one 62 degrees. What does this one have to be? How do you know? Okay. The TriangleSum theorem is going to be the next piece to your foldable. Okay? And we're going to add that in just a minute. But Julian just said that the TriangleSum theorem is, say it louder, all the angles in a triangle, all three angles sum to be 180. So if I know that, what's the missing angle? What's the degree measure of it? Right now, what's the sum? 112. So we have 180 minus 112, 68 degrees. That's what the remainder would have to be. All three are smaller than 90. So it's a acute triangle. It's not equiangular though. It is acute. So just draw that in for us. We should have all the examples of our triangles here. If I ever ask you to classify your triangles, you should be able to use these words. On a future quiz or test, I might say something like classify by size, classify by angles. Before we go on to the next one, let me give you a picture. And I want you to tell me, based on this picture, all of the different kinds of angles, or all the different names of a triangle. So I want you to classify this fully. All right, we know one thing. Give me one name. I can tell you it has lots of names. Let's see it. It is equilateral. Even though the sides are not marked congruent, it is congruent. All right, give me another one. Jonathan. It is acute. I agree. Is there something else that it could be, India? It is equiangular. There is one more. There's one more. It is isosceles. Go ahead and do that, Josh. Good. Isosceles. Because isosceles says at least two. So every single equilateral triangle is also isosceles. Okay? the hint because you'll see this when you teach your quizzes. Okay. If you turn your foldable up to the next page, be careful when you fold it up because you don't want to kind of crinkle your triangles here. So we're just going to, you want them to stay folded. But only on the top here, you're going to label it TriangleSum theorem, and I want you to put this example there, okay? So just on the top, you're going to call it the TriangleSum theorem, and you're going to put the example right there on the top. So I'm always amazed that you guys just believe me. You just say, oh, okay, all the angles are 280. I'm going to prove it to you, okay? Because I don't think that it's fair for you to take it face value, okay? So do you agree this is a triangle that I'm showing you? Yeah. So his is a triangle, okay? It can be any triangle, doesn't matter what I'm going to give you one. I'm going to rip off all the angles. Do you agree I did that? I ripped off all the angles, right? Right. So now what I'm going to do is I'm going to make them so that they equal 180. Get my tape together. I'm going to tape it up on the board. Come over here. All right. So let's see. Start there. Add that one in there. And squeeze that last one over. Do you see how all the angles in there together? I pointed them. Don't they form a line? Well, we know something about a line, don't we? What does a line always add up to be? 180. So no matter what kind of triangle you have at all, if you rip off all of the angles, they'll always form a line. So they always add to 180. Okay? So we know that to be true. So in this example, I've given you some of the angles. Good. How could I find out? Tell me what, if I was going to do an equation. Okay, I know we did it kind of already, but what would the equation be? What plus what plus what equals 180? 28 plus 134 plus equals, all right, we know how to solve, right? So what's 134 plus 128? 162. Then I have to subtract that from 180. Would you agree? Over here. There we go. So I'm going to subtract 100 and 162. What's 180 minus 62? 18 degrees. So that's what X is. You should put that in your folder. Okay? I want you to make sure that you have that degree measure there. All right, we have one more piece that we're going to add to our foldable. Okay, one more, and it's called the exterior angle theorem. Oh, yeah. Lots to do today. This is the example I want you to put on the bottom. Okay, and then we're done with today with the foldable. So the exterior angle theorem. So we have the TriangleSum theorem and the exterior angle theorem. It goes on the bottom. Is really knowing what kind of angles we're talking about. So here's a vocabulary word you may not have heard before, the remote interior angles. We know what interior means. What does interior mean? Inside. So we know they're going to be inside the triangle. They are called remote interiors because they are the two angles that don't touch the exterior angle. Okay? So the exterior angle is on the outside of the triangle, and its two remotes are the ones that don't touch it. So the other two. Okay? So the measure of this exterior angle is actually those two added together. Believe me? Let me show you why. Let's look at this situation. You don't have to write this one down if you don't want. If you want to put it in your notes, you can. But go ahead and look at this example. Okay? How could I write an equation to solve for x in this case? What would I do? Anyone? 140 equals 2x plus 40. Totally agree with that. Let's do it using the theorem, just like Deshay said. She's exactly right. Let's go ahead and solve it, and I'm going to show you it a different way to show you why it works. If we subtract 40 and we divide by 2, do you agree that x is 50? Yeah? Okay. Which means that this angle would be what? 100. Okay, good. What kind of a triangle does it make it? An obtuse triangle. What if you were... Yes, Lucia?
You're gonna have to like another
All
one.
right, give me the other one.
You like, since that's a straight line, you do 180 rather than 40.
We have a linear pair, don't we? So she's saying with the linear pair, I know this is 40 degrees, if they have to be 180. If that's 40, don't all the angles inside of a triangle have to add up to 180? So this is going to be 40, 40, which means that one has to be 100. So either way will work. So sometimes you don't need the exterior angle theorem. Okay? Sometimes you can do it Lucia's way. Perfect. There are occasions where you have to use it, and there's no other way around it. So that's why I'm teaching it to you. Okay? Good. Excellent. I've got some problems I want us to work on. There's 14 of them. Some are easier than others. Okay? So let me pass this out to you. I only want you to do the first page. There's some word problems on the back that we'll get to eventually. So let's look at the first page. Can I talk to you about number 7 for a minute? Okay. I want to kind of help you a little bit with number 7. So I've drawn a similar picture. Not exactly the same, but you get the idea. I want you to treat them as two different triangles. Okay? So I want you to find the missing triangle on the right, or missing angle on the right-hand side. Okay, what's the missing angle? I didn't get 83. I just got 80. I just got 80 as well. Is that what you got? Yeah. So 80. So I agree. This is going to be 80 degrees. And I'd write that on my picture. Okay, I agree. It is 80. What do you notice about these two angles? Josh, what do you notice about them? They're vertical. Which means what's true about them?
Yeah, congruent.
They're the same measure. Okay, they're congruent. So if this is 80, that should help you find right? So that should help you find the measure of x. Do you agree? Does that help? Okay. Just want to make sure we're on the right track. If you'll take a second, just for a minute, and look at the very bottom. And look at question 14 for me. Can you look at that one? Because this one's another one that's going to be a little tricky. So 14 is a little bit tricky. So I'm just going to kind of get you started a little bit with this one. Yeah, 14, the last one down. The 30, 36, okay. We're trying to find x. Your hint is, the first thing I want you to do is I want you to treat this triangle on the left as its own triangle. It's a maybe. Okay. So if I treat the purple triangle like its own triangle, I can find the measure of this angle. Would you agree? What would it be? That'd be 112, right? And then 180 minus 112, 68. So I know this angle right there is 68 degrees. Okay? Then guess what? We can look at the blue triangle now. And I can find, based on the blue triangle, this angle. Can't I? Does that help you get started? Because once I find this one, then I have this little triangle inside, don't I? And treat it separately. Then you know that it's vertical. To kind of give you a process there. Now, you're going to have a separate homework assignment. Okay, so this is going to be graded. Hopefully you have enough time to finish. We still have almost a half an hour, so we should have plenty of time. I will write your homework problems up on the board, and then you just, that's it for the weekend. So this is your homework from the textbook, okay? And then that will be due next class, which is after, we have a holiday, don't we? It's after, is it it Veterans Day? Okay, I can do it in the name of God. Yep. So get this done. Get these 14 finished. When you're done with them, go ahead and turn them in, and then this will be your homework.